Hi there, my name is Robert Kalman, Product Marketing Manager in Renesas Europe's Industrial and Communications Business Group. I'm taking care of our high-end microcontroller and microprocessor products, and I'm here today to introduce the new RZ A1 family from Renesas. I'm going to talk a little bit today about what the product is. I'm going to talk about why we've decided to release this product and just exactly what advantages this product can have for your applications. The human-machine interface, or GUI market, has really gone through a revolution over the past few years, mostly being driven by the mobile phone market. Consumers are requiring bigger screens, more intensive graphical applications, and a more captivating user experience. This trend is coming into the white goods market. The number of coffee machines, washing machines, and other white goods applications which are going to be fitted with a TFT screen in the future is rising at a dramatic pace. It's not just the washing machine and white goods market which is increasing. Advertising appearing in more and more unusual places is also leading the development of more graphical intensive TFT screen applications. The market today is split into two. At the lower end we have microcontroller solutions such as the RX 600 from Renesas, which have their own disadvantages and advantages. At the higher end we have microprocessor solutions which again have their own disadvantages and advantages. On the microcontroller side, you have a single chip solution which is obviously very simple and very cost effective. However, limitations in terms of the size of the RAM and the speed of the flash mean that driving a screen larger than QVGA or wide QVGA is often very difficult without making compromises to the system. On the other hand, we have a microprocessor solution which has almost limitless RAM and limitless flash, whereby you can run at a very high performance, very high clock frequency. However, it's a 3-chip solution and therefore you have a much more costly final solution for your application. Between the two, there is nothing today. The RZ A1 is different. It's a so-called embedded MPU sitting between the microcontroller and the microprocessor world. It includes up to 10 megabytes of on-chip SRAM, which means there's no need for external SRAM. It allows for running code and booting directly from an external serial or quad-speed SPI flash, which means that rather than a 3-chip solution on the microprocessor side, we can choose the same performance level but a 2-chip solution on our embedded MPU side. The RZ A1 from Renesas also offers additional advantages over the microprocessor solutions. The PCB costs can be reduced because we offer a QFP package, which means rather than using a 400-pin BGA package, a QFP package can be used, and instead of a multi-layer PCB, you're using a 2-layer PCB. Additionally, having the internal RAM on the chip itself means that you no longer have to provide 1.8 volts for that external RAM. And finally, as the high-speed signals accessing the RAM are on chip rather than going through an off-board bus, this means that actually the EMC performance can be significantly improved compared to a microprocessor solution. The device includes all of the connectivity that you'll need for your application: 10100 Ethernet, USB host, USB device, and CAN, as well as many serial ports as you can possibly use. Critically, the device also drives a screen up to 1024 by 768 pixels with 24 bits per pixel color depth. In fact, possible even to drive 2 screens simultaneously. The device also includes 2 inputs for 2 camera interfaces, so that 2 cameras can be used simultaneously, which is perfect for vision applications. And of course, don't forget that 10 megabytes of embedded SRAM. A special feature of that 10 megabytes of RAM is actually the bus connectivity. In a typical microprocessor application today, you end up with 3 accesses happening on the RAM simultaneously. The CPU is running its code from the RAM, the LCD controller is taking the current picture data and driving that to the LCD screen, and the CPU is also writing the next picture data into the buffer on the RAM. This means there's a lot of traffic on that RAM bus, and also means that this can be the bottleneck in many applications. The RZ A1 again here is different. The 10 megabytes of SRAM are split into 2 megabyte blocks. 5 of them are connected then to the CPU, which means that the CPU can run its code directly from one block. The CPU can be writing the next picture into the next block, and at the same time as that, the LCD controller can be accessing a third block, all of these blocks having their own dedicated bus. Which means although the device is only running at 400 MHz, we're actually able to provide human-machine interface applications at a performance level comparable with a much higher frequency. The device also features an Open VG hardware acceleration unit. This means that operations can be done using a lot less CPU performance and also saving a lot more memory. If you compare vector graphics, which are supported by the Open VG unit, and bitmap graphics, you can see the difference quite significantly. For example, in rotation applications, where you're rotating an image 360 degrees. In a bitmap image, the easiest way to achieve this is simply to save the image 360 times in your memory, each rotated by a single degree, and then show those 360 images one after the other. In vector graphics, that's supported by hardware, the rotation, so you only need to save the image once. Also in vector graphics, this rotation doesn't mean that there's any significant access to the external flash memory, which means that performance can be increased even more. Another advantage in vector graphics is giving a higher quality image. In zooming applications, as you zoom closer and closer into a picture, a bitmap will very quickly become pixelated and not look so good. Vector graphics, on the other hand, never have this problem, and your graphics look as good as they can do as far in as you can zoom. Renesas is working with a number of partners in the embedded workspace. We're able to provide partner solutions in terms of our real-time operating systems, such as solutions from FreeRTOS, Sega, Express Logic, and Micrium. We're able to provide human-machine interface applications with our partners from Sega and Altia, and tools solutions from IAR, ARM, and also from Renesas ourselves. With this bundle of different partners, we're able to provide a captivating solution which allows you to pick and choose exactly which your application needs to create the perfect HMI design. In the demo, we'll see exactly what's possible from an embedded MPU solution. We see here software running from our two partner companies, Altia and FreeRTOS. It's using the Open VG graphics accelerator and showing some very nice scrolling animations. It really provides a very captivating user experience and runs directly from the 10 megabytes of embedded SRAM. This is running the code and also including all of the frame buffers for the animation. This means that customers can use a two-chip solution and provide a low-cost solution but still meet the requirements of their customers who are requiring a captivating user experience, as you can see here.